So I just try to cover the basics of pointer actually. So more will be given in the books actually. So and like we saw like how to allocate a memory in the heap actually. So sometimes whatever you allocated um, like suppose if you allocate this memory, if you see that m number, right? So after allocation is finished, if you forget to free the memory or try to use this variable to some other location, to point to some other location 0x00 something like this, what happens is the memory that you allocated, it's not freed. It is a leak, memory leak. We call it memory leak actually. So what happens is when your program is running, suddenly you will see the memory getting like spiked in the process. So for example, if you see here in task manager, you will see memory here. Suddenly it will bound actually. It will spike and it will be uncontrollable. So because of memory leak. So it should be stable. Whenever your program runs, it should be stable actually. What you allocate, you should delete it actually. Um, so what you have to do is like you should not have a memory leak actually. So there are certain debugging tools available to check whether your program has got any memory leak actually. So in HaloCore we face this issue actually. So suddenly like when server try to run, it will spike actually. It will never come down. It will just go on increase. Then we just forgot somewhere to um, like free the memory. Then it started to be stable. When it increase your memory speed, that when it increase the memory, it will slow down all your entire computer will get slowed down actually. So when you are writing a program, the client place or a server, it should not slow down. It should not affect their server. Actually, it should be stable. So that's why Java don't have pointers, because all such things user has to take care of themselves. That's why they have garbage collector, right? So here there's no garbage collector. So we have to collect all the garbages. And suppose and what is it? So memory leak, like if you just fail to deallocate this memory, it will be a memory leak. Okay, and suppose what happened is you free this memory, but you fail to initialize this with null or some other valid address. It will be called a dangling pointer, like hanging pointer. Like dangling means hanging, right? So a pointer which is pointing to a wrong location actually. So it is pointing, for now it is pointing here, but you freed this space, but you didn't clear this one. You see this, you see there 5 6 7 8 is there, right? So you have to reinitialize it. So if you don't reinitialize, it will be dangling point. It will be pointing to nowhere else. And if someone try to access like memory, you will try to access a freed memory. So again, your program will crash. So that's why like memory is a little sensitive. That is why I said like just instead of studying from the website, you just take the book and proper book and just go through the procedures and steps. So Many other things they will cover, but I didn't cover actually. So maybe. So now you know the difference between malloc and new, right? So you know in Java that operator overloading, operator overriding. Is there? Have you studied overriding? You know overloading, operator overriding, overloading. You didn't. You don't have that one. You know it. Forgot. Okay. They didn't teach you so you don't have operator.
Function overloading.
That is there, but the operator overriding. Okay. So now you know the let me think how to tell you those things. Okay. So now you know the constructor and destructor. So what is the use? Suppose you have a pointer variable int char p m underscore p, maybe some integer number 2 like that. Okay. So the first thing that we have to do is in the constructor, either you allocate a memory or you just initialize with null. You can do the same thing here itself. That is in new C++. You can also do this here, but I don't know why it is not allowed. Null is not that defined. Null PTL. Maybe we have to use this null PTL. Okay, let me not go into that. So, or you just initialize inside the constructor. So now you are writing a function, say void allocate int something like this, and you are allocating a memory for this one. Maybe I will allocate using malloc int star m o c just one int. Okay. Size of int. That's it. So, and you are trying to use this variable somewhere you want in your program, and after you finish, what you have to do is you have to deallocate. So, free, that's it. So constructor will allocate, or wherever you want you can allocate, and the constructor if you have to deallocate. But before deallocation you must check whether it's not null. Okay. That's it. That's the use of constructor and destructor. So, so constructor normally you initialize, and destructor where you destroy the space whatever it is, or you can just suppose you're using some value here, maybe 100. You can just make it 0 here. Not only for freeing the space, but also some reinitializing with some variable. So like this also we can do actually. So, okay. So let me tell you about this operator overloading and operator overriding. So suppose um, so you can add two numbers. What that is a plus b actually. So now we want to add two struct actually. So how do you do that in C++? So let me see. Struct, and the output of a plus b is like two integers. When you add, what is the output? It's an integer, right? So same way, when you try to add two struct, it should be a struct only, right? So you should return a struct, and then operator plus, and you should take constant struct1 reference. You know the meaning for this one, right? So you know, right? So maybe struct1 constant struct1 ampersand struct2. Happen. Okay, so what I had to do first, set one dot, maybe that is the numbers, plus set one dot set two. Sorry. Will it work? I don't know. So what it means is you are just adding two struct, and you are returning the number. It shows that you are returning the number, but actually you are returning a struct. So this, okay, what is the error here? No suitable constructor exists to convert from int to struct. So I can say is the struct 3, maybe struct 1, struct 3. You can store it here. And then return struct 3. Let me compile this. Okay, I'll just comment this one. at least now do you remember this one? Are you able to remember? In Java they didn't, okay, you don't have operator overloading overriding. Okay, what is the use of this? Okay, so let me do it here itself. So we are having struct one, maybe str1, not stru1. Okay, and you have struct 1, maybe you have stru2, you have a struct ruct struct3, sorry, struct1 stru3. Now we are initializing the value dot maybe 100, initializing the value 200. Okay, so we know if you have an int c equal to, sorry, you have like this, a equal to maybe like a b c, and then initialize a equal to 100, b equal to 200, c equal to a plus b. So you know this one, right? So it will just add two numbers and store it in C. Same thing you can do for this one. So I just initialize with 100 and 200. Just initialize struct stru1 plus stru2. You can how this is possible is, in behind the scene what happens is it knows actually, so it will be like, it will be calling this operator. And then stru1 comma stru2, just a normal function call, right? This is a normal function call. Only thing that's something special at operator plus actually. It's the normal function call. It will return a value, or it will return another structure. Just to make it comfortable for developers, to make it easy, you just add two structures. So this is what happens behind the scenes. So I just showed you operator overloading. This operator overriding also is there, but that is you declare this operator inside a structure. So you can override many things. You can override plus, minus, plus, plus, minus, minus. You can override a bracket, open bracket, close bracket. So there are list of overloading and overriding functions available. So which will make your program to look comfortable and easy. Like, so this looks nice, right? It looks okay. You are storing some value and you are just adding to. It's a user defined type, right? So you are able to do as if you are doing like a basic data type. So it's like that. So that's the use of operator overloading and operator overriding things. But I didn't cover much thing. But maybe you have to study by yourself actually. Okay. Maybe that book which we have bought, right? Those things, there's a chapter, I think, actually available. You can go through it. Now, what I wanted to do is, okay. Normally, you have this function inside a structure. It's a member function, right? This is a member function. After you compile and after when you load your program into the process, what happens is, when you just try to look at the assembly code, right? Normally your function won't look like this. Okay. Your function will not be like a function name with a parameter. No, it won't look like this. So internally what goes on behind the screen is, it will be like this. So we have a struct. Maybe this is what it happens in your program behind the scene. Suppose if you have one more function, maybe we'll call it as some function and some parameters, maybe int in some param, then wchar underscore t, some param wch, maybe not pointer, so wch param, and you are trying to do something with these parameters. Okay, you have written a code like this. So this is what the developer sees, right? So it's a member function which requires this parameter, but internally it stores like this. So I'll just copy this one. If you see your assembly code, it will be a normal function only, not a member function. It will be a normal function, but it will be passing this struct additionally in the first place. So your function will look like this internally when you look at your assembly code. So it will be a normal function with additional thing is, will pass a structure actually. So what happens is, you just rename this struct one to define any name, right? You can internally you can have any name, right? So I'll name this one as this. So that way you can access this. You see, this is nothing but a pointer to structure of its own in the own memory actually. So nowhere this one is declared. It is not declared. This is not declared actually. But still you are able to access your values. So this is nothing but it's structure actually. Structure. It's a pointer to this struct one. So in Java you have this, right? So, but actually internally see this is what it happens. So struct this. So, but this is hidden from the user side. But actually we are accessing this parameters, the first parameter. You can assume that this is the first parameter, but actually internally it sees this one as the first parameter, and the name of that first parameter is this, and which you never see it, but you will only use it as this. So that's the concept actually. So understood, right? Okay, we'll just now pointers. I don't know what to cover. Think that you have to practice it, and whatever the book teaches you, that you have to. But don't follow all the what I taught you, that notations. Just change it to x64, and just whatever the book says, you just try it. Don't follow any notations and all, because you need to understand pointers more than all these notation things. So whatever the book says, you just try it. Except you try it in x64, but only if they tell you to change it in x64, x64 and x86. x86, we just change it and see it. So that's one thing. Anything else in pointers? Nothing, right? So I was array and pointers. Whether we have a two-dimensional, multi-dimensional array also, the behavior is same. But that book will explain how to access a two-dimensional array, three-dimensional array. So those things all will be available. Just I tried some basic thing. Okay. So, and you know the structure, behavior of the structure. So I still wanted to go inside. Next, I wanted to tell you about the runtime polymorphism, and it is very, very important to know this one. Any C++ guy who understands this one, they understand C++ entry completely actually. So, so to make you understand that runtime polymorphism, that's why I just covered this one. So how internally it's represented. So actually there is no declaration for this, but still internally you will be calling, it will be using it, but it's hidden from your side, and that's why we are able to access this. So okay, in Java you have used this, right? Okay. So operator overloading, you know, operator overriding also, like something similar kind of thing. Okay, so now you remember, right? Okay, so whenever you come across the operator overloading like this, don't get confused. You just replace that plus with operator plus, like a function call. That's what it happens. It's a compiler level programming actually. So compiler will internally it will change this plus to operator plus, and then it will try to compile as usual. So operator overriding also something similar. Okay. Now just want to just introduce the runtime polymorphism. Maybe if I have time, maybe now or tomorrow I'll tell you how internally it works. Okay, let me take one more project. It's fine, right, up to this. So pointer you will be studying more. Okay. Okay, runtime polymorphism is one of the important, like a little difficult to understand, but I will just make you to understand with examples. Okay. So the behavior of this global alloc and virtual alloc is same as malloc. Only the new and delete will call the constructor and destructor. So, and global alloc and virtual alloc, you have to typecast and all those things you have to do as usual. So you have to keep it in mind actually that what is the purpose of this and how it internally it's used, all those things. Okay. So let me define a class. Okay. I don't know, maybe base class. I'll make it for now as public. Int m underscore n number 1. Okay. And you have a function. Maybe y. So if you don't have a constructor and destructor, it will have a default constructor and destructor. So it will internally it will have a default constructor destructor. So let me do this. One in this. So you can define within a function, or you can also define outside the function, means outside the class. So how will you define outside the class? Yes. I have given a declaration, I have to define that function. It says like function definition is not found. So how will you define?
Base class scope resolution operator and
then
some memory function one.
Yeah. First of all, return type void, okay, and the base class. Scope resolution operator. This one. We can also override this one. Scope resolution operator. I think yes, and then the function name. So now it's defined. This is declared and this is defined. Okay. Now let me write one more function. Okay. Let me have a derived class. How will you inherit?
Column public.
Yeah. Public.
Some
base class. Okay. Maybe I will define the same name. So I'm overriding it. So some function one, some function. So how will you define for this one? How will you define? Some memory function. Why?
Some memory function.
No. What? Yes, derived class, colon. Is the member function of this derived class. So I have a base class, maybe one. And derived class. So it calls accordingly, like how we are calling what we wrote this way, right? So some function base class and some function to base class will be called. Same way as derived function also will be called actually. So now I will declare a pointer to a base class. So base class pointer to b1, letting it to null. Okay. So in C++, if you have a base and derived class, you can assign a derived class object to the base class pointer. Suppose if you have an int pointer p n number, maybe I will declare one int object, int n number equal to 10. So I can declare assign an address for this one. Suppose if I have an object to int, not int actually, maybe wchar underscore t wch name. I can do like this. I can do assign an integer variable to an integer pointer. But in order to do this one, maybe I will declare int star p in number 1. Let's see what happens. It says some error, right? So value of varchar cannot be initialized to entity int star. Actually, you can typecast and all those things, but it is generally an error, right? A kind of error. But in the case of base and derived, in the case of inheritance, you can suppose I will declare this one here. I will declare here. So you can also initialize with b1. Okay. Suppose you have another pointer, you can also initialize with d1. In this case, there won't be any error. It is acceptable. So base class pointer can point to a derived class object. But in this case, a different type. This is also a different type. This is a derived class. This is a base. Both are different types. But according to inheritance, actually this is allowed. So that is one thing, pointer related thing. So I'll just comment this. So what I was trying to tell you now, I'm assigned b1 to a pointer to a base class pointer, right? And d1 to a base class pointer too. So let's try to call this sum function. Let's see what happens. Same way I'll call two functions. Now let me call the derived class point. Using the base class pointer, I am calling the function of derived. Okay. So, okay, this should print. Maybe I will split this one. Okay. So you have a code here. You have a class here. So the base class object assigned to a base class pointer, and this should print the base class function 1, right? So you should print this one. This you should print this one. Same way this should print this one. Same way you have a derived class object assigned to a base class pointer. So we are calling some member function. What it should do is it should call the derived class sum function 1 at this place, and at this place you should call this function, right? Okay, this is one of the nice tool actually. You can split and you can, if your program becomes large, you can split and see your code actually. So, okay, so let's see what happens. I'll just run it. What happens? Forget about this one. You are using the object to call the sum function 1, and this is the base class object to call. You are using the direct object to call the sum function 1 and sum function 2, and derived class object to call sum function 1 and sum function 2. But using the base class pointer, you are calling the sum function 1, right? But instead of calling this derived function, it is calling again the base class. Okay. So, okay, first let me debug and show you. So this will, I'm using the base class object. Okay, so this should call me the base class function. So it is calling base class function. So next is I'm calling using derived class object. I'm calling derived class function. So it is calling properly, right? Derived class function. Now I'm using the pointer now. I'm using two pointers, one pointing to base class, another pointing to derived class. So let's see. So the pointer which is pointing to base class, it's calling properly sum function 1, sum function 2. Okay. Now the pointer pointing to a derived class should call derived class function. Let's execute. Oh, derived class function should call, but it doesn't call. It calls the base class function only. Okay, I'll tell you the reason for that one. Okay, I'll just finish this. See, you are assigning the base class address and the derived class address to a base class pointers. At the time when you compile, the compiler doesn't know the address, right? Only when it is loaded in the process memory, you will know the address. So what it will do is, this base class, since it doesn't know the address of the whatever it is pointing to, whenever you call any function, it will replace this base class function itself. So based upon the type, it will call. So what is the type of PB1 is base class. Irrespective of what value it is pointing to, it will ignore it, because the compiler will do it like that. So it will ignore all this initialization, whether it is base or derived. It just sees the type of PB1 and call this base class function. So this will call base class So compiler compiler knows the address of this function actually. So it will call the relative address. So you don't bother about those things, but it will replace that with that function call, with the base class function call. Some member function. Yeah. So internally it will be call base class member function. So same way this one. So based upon the type it will call. So call some two. So similarly, what is the type of this PB2? Base class, right? It won't see what it is pointing to. Okay, let me call directly this base class. So it will be something like this. So based upon the type, it will just call the using the pointer. It will just call that particular function. So this is a problem actually. So I don't want to call whatever the base class type is. I just wanted to call based upon the derived class type. I mean derived class object which is pointing to. So what I have to do is I just need to one qualifier. I don't know what you call virtual. Let's see how it works. Let me compile. Let me build debug. So it calls the base class because calling from the base class object directly from the object. Same way derived class. It calls the derived class. Okay, now let's see what happens. Okay, base class some member function. So now here is the thing. It calls the derived class. Okay, I'll finish it. Just adding this virtual makes the thing work properly, but this is not enough. You must know like what's going on behind the scene. Something like this, and whenever the function call is there, a member function you call, what's going on behind the scene in the assembly language, it will be just a normal function with one additional parameter which is hidden from you. Okay, so we have to see like what's going on behind this, so that it is whenever I give the virtual, it is making use of this object and then is calling. Okay, that's what next we will be going through. So we have time. It's going to be 1. So we'll continue this one tomorrow. Shall we continue tomorrow? So now you know the reason, like how to Uh, so what is the use of this? Why don't we just create an object and just call a function? Why don't you do it like that? Instead of having a pointer and just assign address to the pointer. Um, okay, let me give you the example. Tomorrow I will explain you the internal working of virtual actually. So how it behaves. That is very very important. So any C++, if you know this concept, you know you can, it's guaranteed that you can understand C++ very well actually. So like almost it took me 1.5 years after I started my career. It took me after 1.5 years I just understood this. Okay. Um, so what is the use of such thing? Why don't you just create an object and call things like that? Now, um, let me explain the use of this. It's fine, right? This is okay. Let me save the recording. Next, I will be telling you the use. Tomorrow, I will tell you the how it actually behind the scene how it works.